A system curve is a set of head flow data which describes the performance of a piping system at a given location. This location is usually a supply pump station. A system curve is useful in determining the pump requirements and sizing for that installation. It can also help to determine the maximum flow the system can handle based on the rating of the pipes. To develop a system curve, a range of flows for the curve is selected. Then flows for that range are forced into the piping system incrementally. The analysis determines the resulting pressure at each flow, and these values are plotted as shown. Here's a very simple system I will use to demonstrate system curve analysis. Before generating the system curve, I want to point out a common impediment to successful system curve analysis. When a modeler knows what the target flow rate is, it's not uncommon to represent that flow as one or more demands at junction nodes. Here is the delivery point, and the flow is set to 2,500 liters per second. This demand is fixed. It cannot vary. This makes this particular setup unacceptable for developing a system curve. Therefore, the piping system must have at least one storage tank, reservoir, open sprinkler or hydrant, or some other free-flowing discharge point so that the flow into the piping system can be varied. I will change this to a free-flowing reservoir node. I will assume the discharge is to atmospheric pressure, and therefore the grade and the elevation will be equal. The System Curve Analysis Setup menu is under the Analyze tab. There are three inputs: junction, flow rate, and available head. The junction is a node that is used to represent the pump station location. The junction should be located as close to the pump station as possible and also should have the same elevation. The elevation for my pumps is 100 meters. The elevation for my junction is 110. So I will want to insert either an additional junction node or configure this junction node to be the same elevation as my pumps. So I can change the elevation to 100. If I want a node placed at 110 just downstream of the pump, I can insert one. I may need to change my pipe lengths. This is 1,000. I'll just make this a very short length of 10 meters. Now I have a junction node at the same elevation as my pumps, and then the next junction node in line is at the original elevation. My junction node is J3. I will go to the System Curve Setup and enter the name of the junction node. Next is the flow rate. The modeler will usually have a target flow rate in mind. In this case, our target flow rate is 2,500 liters per second. The flow rate here defines the range of data in the system curve. So what you really want is a value that is larger than your target flow rate. My target flow is 2,500 liters per second, so I will use 5,000 liters per second. Last is the available head. The amount of head available to the pump station can have a notable effect on the pump performance, so it is an important parameter to correctly represent. Consider the elevation of the pump station. In our case, this is 100 meters. The available head is the amount of head above the elevation of the pump station that is available for the pump. The grade for our supply reservoir is 110 meters. The available head is the difference between these two values, 100 meters for the pump and 110 meters for the reservoir. Sometimes pumps are represented without a reservoir, so let me just show that real quick. Pumps may be modeled without a connection on the inlet side. In this case, the grade is directly input into the pump data, and our grade is 110. And just like with the reservoir data, the available head is the difference between the grade and the elevation. Back in our system curve setup, we enter an available head of 10 meters. And there's one more important step before we're ready to run the system curve analysis. And that is we need to turn off the pumps. If the pumps are on when the system head curve analysis is run, it will interfere with the pressures in the curve. Now we are ready to run the analysis. Back in the Analyze tab, the next step under the system curve setup is to run the system curve analysis. When we click on this, we get a modified analysis setup menu that targets our system curve analysis, and we can hit Analyze. Once the analysis is complete, we can click on the next step in the pump system curve section, which is to display the curve. To display the system curve, we check the box here, and we can select the pump curve, ID number 1 in our case, to plot along with the system curve. The location where the pump curve intersects the system curve is where that pump will operate. If we installed a single pump in our system with this curve description, we could expect the flow rate to be around 1,400 liters per second. With the multiple pumps in parallel, zooms out and it's hard to see exactly where this intersects, so we could change our plot ranges here. Let's make the maximum flow 5,000, and the head will go from 40 to 60, and uncheck use default. So I can expect if I have 2 pumps in parallel that my flow should be quite close to my target flow of 2,500. So 2 pumps in parallel is a good fit for my target flow. So the pump intersects my system curve very close to 2,500 liters per second. We can go to the report, and there is a section summarizing the system head curve data points. So we have the flows through our specified range and the resulting head or pressure values that we calculated for each flow rate. If you have multiple curves that you want to try out with your new system curve, you could input those as in different IDs and use these drop-down selectors to display the different IDs. To enter multiple pump IDs or multiple pump curves, you can go to Devices, Pump IDs, use this selector to bring up new blank head versus flow data tables and input the curve data for as many of these as you like.